So I welcome you to day 9 of the 30 Days Tech Career Challenge. Okay, so this is a training series for you if you want to begin a career in tech. So the training is slated for 30 days episode structure. Okay, whereby after day 1, you move to day 2, day 3, day 4. Okay, so far we have covered day 1, covered day 2, we have covered day 3, we have covered day 4. Okay, we have covered day 5, and we have covered day 6. We have covered day 7. We have covered day 8. Okay, where we configure our first network. You can get the link to all of these previous days in the description of this video below. Okay, and this is day 9, where we'll be talking about OSI layer model. Okay, if you have not subscribed to the channel, go and subscribe right now. Go and subscribe, go and subscribe, go and subscribe, go and subscribe and like this video. Let's go to the class.
So in this lecture, we'll be talking about OSI layer. Okay, OSI layer. Some people can call it for you OSI layer model. Okay, OSI layer model. So now, this is very simple. Some people do get confused with it. In fact, before I was able to understand this, I also got confused a lot. And also during my days in school, my lecturer taught me OSI layer model, but it was in the fashion of cramming. We were only cramming what these layers is all about. So now I will be breaking this down for you so that you will understand what this is all about. So now imagine you now, you want to send a message to your friend during the time of writing love letter. Okay, let's say you want to send a letter to your girlfriend. Okay, to your girlfriend. You are sending a love letter to your girlfriend. Okay, if you live in the days of writing letter, posting letters, you understand what I'm talking about, because there was no phone then. There was no Instagram, no WhatsApp, no nothing like answered. So now we normally send letter to people. Okay, by the way, companies still send letter to some people these days. So now you can still relate that to what I'm about to explain here. So now, this is the letter you want to send. Okay, you have composed the letter, you have typed everything you want to type in the letter. I love you, blah, 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 blah. I can't do without you. You are the sugar in my tea. You are the cockroach in my cupboard and all of that. You have write your letter, right? So now you need to fold this letter, right? Fold this letter and put it inside an envelope, right? Okay? Follow me, please. You need to fold the letter, then put it inside envelope. Agreed, right? So when you put it inside envelope, you need to buy what is called a postage stamp. Okay? Postage stamp. Then if you have sent a letter before, you know what I'm talking about. Postage stamp is what you put at the back of it's just like a small sticker that you put at the back of a letter, just to show that it has been approved by the post office to be sent. So now you will have the address. We had the address. Maybe the person is living at a street ABC, Aso Rock, Abuja, Asokoro Estate, Abuja. Okay, then you take the letter to the post office. Okay, you take the letter to the post office. It is at the post office that they will now send this maybe through their delivery fan or dispatch rider, delivery fan, or dispatch rider. Okay. So it is the delivery fan or the dispatch rider that will now deliver this message to your girlfriend. Okay, to your girlfriend. So your girlfriend will start to open the message, receive the message. She will receive the message, open the message, check whether, okay, before she open it, she will check whether it is her name that is on the letter, right? Check whether it is her name on the letter, then open it, read the message, okay, interpret the message, okay, interpret the message, write his own message, and reply you back. Just the same process, okay, by following the same process of putting the message in the envelope, stamp the message, put the post office address, PO box, and all of that. Okay, are you following me? So now, all these processes that take place, all these processes of getting an envelope, stamping the letter, and all of that, computer also used to do something of this nature. Okay, something of this nature. So now, each of these steps that you just taken, to get the letter ready and be sent through post office, each of these is now divided into layers. Okay, don't worry, I will show you how computer does its own, but just make sure that you hold onto this analogy that I just gave you. Okay, whereby you follow this process to send a letter to somebody, or maybe you want to send a message to somebody in Ibadan or in Abuja or in Lagos or anywhere you are, you will still follow the same process. So all this process is now broken into layers. So let's say this is layer 1. Okay, let's call this layer 7. Let's call this layer 6. Let's call this layer 5. Let's call this layer 6, layer 4. Let's call it layer 5, layer 3, sorry. Layer 2, let's call this layer 1. Okay, so this letter was sent through the dispatch rider. That means your girlfriend will begin at layer to receive the message. He also will follow we have his own layer as well. Okay, the process that your girlfriend too will follow here, let's say it is also in layer. Okay, so now let's now relate this to a computer, to systems. How systems also make use of layers to communicate. Actually, it is not a physical layer. It is just a concept. It is just a concept to understand better how a network works, so that when there is an issue on the network, you can easily know which layer to focus on. Okay, which layer to focus on. Let's say you make a mistake on the address that you have to put on the letter. That means such letter will go to the wrong address, because post office person will not know, this file reader will not know. His own job is to take a letter to the address that you give them. So now, computer today, they do all this checking to see if the address is correct, to see if the message is going to the right destination. So let's go and see how this is related to a system now. So let's relate how this happens when two systems are communicating. Okay, when two systems are communicating. So now let's say this is system A and this is system B. Okay, this can be a laptop, it can be a desktop, this A can be a desktop, it can be a phone. This B2 can be a system, can be a laptop, can be a phone, can be a server. Just think of anything system, okay? Anything that can be connected to the network that can receive IP address. So now, we call something protocol. Protocol. Computer use what is called protocol to identify what a traffic represents. To identify what a traffic represents. Okay, to identify what a traffic represents. Computer use protocol to do that. So we have different protocols. Okay, the protocol we'll be looking at is called HTTP, for instance. We have a protocol called HTTP. Okay, Hypertext Transport Protocol. Okay, I think that's the full meaning. So we'll be looking at this protocol called, we'll be using it as an example in this our scenario. Okay, this HTTP protocol is normally used for anything web traffic. Web traffic. Okay, anything that has to do with web, with websites. You open a website, you type facebook.com. What that traffic we leverage is HTTP. Okay, you open your browser, you type instagram.com, you type this.com. Okay, behind the scene, the protocol that message we use is HTTP. So HTTP is for web, for instance. Okay, is for web, for instance. And every protocol has port number. Port number. Port number is what a computer will use to instruct the recipient, the receiver system, the receiver, that this traffic that I'm sending, it represents web traffic. Okay, let's say computer A is want to access Facebook. That means it will follow HTTP traffic, right? It will, this same system A will add what is called port number. Okay, for instance, port number for HTTP is 80. Okay, 80 or 443. Okay, this one is for plain text, while this one is for encrypted web traffic. Okay, plain text means anything that is transferred between these two systems is in plain text. If anybody intercept this, they'll be able to see what is being transferred over the network, maybe through a cable or anything. So now, encrypted traffic means what is being transferred through this is encrypted. Nobody can see it. They will see some message that can be interpreted easily. Let's say I send Facebook from here, or I send Facebook from here. Okay, if this Facebook is transmitted over this network media now, if anybody intercepts it, you'll be able to see Facebook. Okay, if I'm using this protocol, if I'm using this port number, okay, if I'm using just HTTP. So now, if I'm using the encrypted HTTP, that one is what is called HTTPS. If I'm using HTTPS, anything that is transmitted over this, nobody will be able to see it. So let's say Facebook is what I transfer, is what is flowing, right? If anybody check this Facebook, check this traffic called Facebook, what they will see is they can see something like this: a hash dollar. They just see something that can be interpreted. Okay, that's the difference between HTTP and HTTPS. Okay, that is why you will see some websites, it will write HTTP, while some will write HTTPS. Okay, so now, that aside, we only digress there. Let's continue what I'm trying to explain to you. So now, the web traffic leverage what is called HTTP protocol. Okay, we'll be making use of HTTP protocol here. And it has port number of 80. That port number is what we tell the recipient that this traffic, this Facebook traffic, represents web traffic. Okay, that's the purpose of this port number, to tell this recipient that it is a web traffic. Okay, it has to do with web. From there, B will now interpret it and say, okay, they are going to Facebook server. B will now be able to respond accurately. Okay, so we have other protocols. We have FTP protocol. We have FTP protocol. FTP is a protocol for file. Is a protocol for file. FTP is a protocol for file transfer. Okay, maybe you have two phones, they are transferring file to Bluetooth. Okay, protocol that traffic will leverage is FTP. Okay, FTP. Maybe that file is music. You are trying to share music with your friend. Okay, so that is FTP. There are many protocols. We have Telnet. We have SMTP. SMTP is for email. Is for email. Okay, for talking to email server. It has its own port number as well. The port number is 25. It has port number of 25. Okay. So now that is protocol, and that is port number for you. So now protocol represents every applications that you operate on a system. Okay. If you are accessing a web through a system, the protocol behind that the system is seeing is HTTP. If you are transferring a file, the protocol that system is seeing behind the scene is FTP, for instance. Okay, if you are sending an email, the protocol that system is interpreting that email is SMTP. And each of the protocol has a port number, and this port number is to signify what that protocol stands for at the recipient's end. Okay, so let's continue. So now let's say system A and system B, they want to communicate. System A wants to send message to system B. Okay, it will also break that communication process into layers. So now let's say we are trying to access this Facebook server. So we type www.facebook.com here. Okay, so now, like I said, this protocol will leverage what is called HTTP. Okay, and this will be represented at what is called application layer. So now let me do it this way. The same way I said, before you send a message, you will follow series of steps, right? So now computer also follow what is called layers. Just the same way I break your own process of sending message to layers. So first layer is a application layer. We have session layer. So I will explain what happened at each of the layer. Just wait. We have a presentation layer. We have a transport layer. We have a network layer. So we have 7 layers. We have data link layer. and we have physical layer. Okay, so now network engineer or network experts, they come up with a concept that communication between two systems can be divided into these 7 layers, and they call it OSI layer model or OSI model. Okay, this was invented around 1980, in the 80s, when they were looking for a way through which 2-3 systems can communicate and how they can easily establish this. That is when they go into research. They went into researching how this can be done, can be achieved, and they come up with layers to guide how this communication take place. So now at application layer, that is where we have a protocol of the message you are trying to send onto the network. Okay, protocol of what you are trying to send onto the network. Let me rewrite this. Okay, so I just bring it to the left-hand side corner so we can have enough space to explain. So now, application layer, what happens here is they call it human interaction, like human interface, where we human that we interfere with the system, where we access the system. Okay, human interaction. Okay, this is where we interact with the system. This is where we interact with the system. Okay, so now you are going to Facebook, right? What the system we see at application layer, a protocol that represents the web traffic, because you are trying to access a web server, is a HTTP. Okay, HTTP protocol. HTTP protocol. Okay, the system just added protocol to your traffic at application layer. Okay, at the presentation layer, system will do what is called formatting. So that formatting means making the traffic you are sending, the message you are sending, making it interpretable, so that when the recipient receives the message, it will be able to interpret it. Okay, it will be able to interpret it. Let's say what user on system A, what that user is sending to system B is a picture. Maybe I'm sending picture through Facebook to system B. Okay, so now for system B to be able to interpret what that traffic stands for, that means there should be a format for that picture. So it can be JPEG. Okay, it can be PNP. Okay, so now what that protocol stands for, the format that the recipient at the B side will understand, that formatting happens at presentation layer. Okay, that when this picture gets to B side, third B side, that it is in JPEG format, so that B system can easily interpret that this is a picture, this is a JPEG. Okay, so that is what happens at presentation layer. So now, session layer. What session layer does is it allows concurrent connection between two systems. So now, let's say we are accessing Facebook server. At the same time, we are accessing Instagram. We are also going to Instagram. Maybe there is Instagram somewhere. There is Instagram server somewhere. Okay. At the same time, we are going to Snapchat. Okay, this is 3 sessions now. This is 1 session. This is 2 this is the one with a Facebook server is a session. The one with a Instagram server is a second session. The one with Snapchat is another session. Okay, your system is keeping 3 sessions now. Okay, so that when Snapchat reply your system, there will be no issue. There will be no interference. When Facebook send message back to your system, okay, it won't interfere with other sessions that you establish with other servers. Okay, everybody is on their lane. Everybody is on their lane. Each traffic is on their lane. So this is what happened at a session layer. Okay, maintaining connection. It has to do with connection, making sure that every connection is on their lane. Okay, that is why on your system you can open as many tabs as you want on your web browser. You can be accessing Facebook at the same time, accessing Snapchat at the same time, accessing your school portal, accessing different websites at the same time. Okay, so that session is separated at session layer. Each connection is separated at session layer. So now transport layer now. Transport layer, that is where you will now add port number. Port number to the traffic that is coming from the application layer. So now, like I said, each protocol that stands for each application you are using, each protocol that stands for each traffic that is traversing your network has port number. That port number is to tell the recipient system what that protocol stands for. Okay, to signify what that protocol stands for. So now, protocol number for HTTP, like I said, is 80. So now it is at the transport layer that your system will add port number to that message. Okay, that this is the port number. This is the, just the same way you add PO box address to your letter when you are about to send it. So now, once the port number is attached, you move to network layer. Okay, you move to network layer. This is where we talk about IP addressing. Okay. Okay, you are telling your system which street, which location. Let's say addressing. Okay, which location that message to be sent. This is where you add your IP address. Okay, it is the system that is doing all of this on your behalf. Okay, it is the system that is doing all of this on your behalf. All these things happen in less than milliseconds. Very fast. You can't see it. Okay, you can only see this using a tool called Wireshark. Okay, maybe in networking advanced class, in advanced networking class, you will know what Wireshark is all about. You can only see all of this in total, how it is taking place using that tool called Wireshark. So now at the data link layer, this is where we talk about MAC address. Okay, so what is the name of the system that owns this message? What's the name of the recipients? Okay, if you remember what I explained about a MAC address, see it as the name that doesn't change. So what is the house number? What is the house number of where we are going, of where the message to be delivered? So once all of this is added to the message, then it can be transported on the transmission media. Okay, it can be transported on the transmission media. Okay, here we have transmission media. It can be cable, it can be wireless, it can be fiber. Okay, that is what physical layer stand for. Okay, so see these are this as the dispatch rider, delivery fan, taking your message, see this as the road, taking your message to the recipient, the second system now, the recipient system, the server. Okay, so all these layers are numbered. This is layer 7. This is layer 6. They call it layer 6. Session layer is called layer 5. Transport is layer 4. Network is a layer 3. Data link is a layer 2. And physical layer is layer 1. So whenever I mention layer 3, whenever you see me mention layer 3, that means I'm referring to network layer. Whenever I mention layer 2, that means I'm referring to data link layer. Whenever you see me mention layer 7, that means I'm talking about application layer. So take note of that. Take note of that. So now, when the message arrives at the recipient, okay, when the message arrives at the recipient side, the recipient as well will begin his own opening of the message to see what is inside. Meaning it will receive the message maybe on his cable, on his wireless, through his own physical transmission media. Okay? Through his own physical transmission media, which is his own physical layer 2. So the same process that take place at the A side, the reverse of it will take place on the B side. Okay? So this is the physical layer. The message will arrive on at the physical layer. Okay. So now, once your girlfriend receives the message, it will receive it from the dispatch rider or whatever delivery person that you use. Okay, the message got delivered on the physical layer. It moves to layer 2, which is a data link layer. Data link layer. Okay, so now it will check the MAC address. You check the address. Is this message for me? Okay, if it is for the receiver, it is for the right person, then say, okay, it is for me. It passed the message up again. It passed it up to network layer. Okay, so network layer will check the IP address, we check what is inside and see that, okay, this message is for us, it is for this street. Okay, your system will go and check the street. You check that it is his name on it. You go and check the street name. You remember my explanation about IP address and MAC address, that I said network address is your location, your street name. Okay, while MAC address as your house number. Okay, so now it will check that, okay, this is for my location, this is for my street. Check it on the network layer. Okay, once it checked that, it will now be like, what does this traffic represent? What is the port number on it? So that it will know what it will tell application layer when this message gets to application layer. So if you check the port number, so it send it to the transport layer. Okay, here we are checking port number. Here we are checking IP address. Here we are checking MAC address. Okay, So now transport layer will check the port number. It will say, it is 80. That means it is port number 80. That means this traffic is for web. So that when it gets to application layer, I can easily tell application layer that this message is for web server, is for our web server. So see what is inside. Okay, that is where the recipients will finally receive the message and interpret it. So transport layer. So now we have a session layer. We have session layer here. The purpose of session layer is to separate session, is to ensure that we have concurrent connection. We have more than one connection between two systems, and this connection does not interfere with one another. So at the session layer, it will check the session ID to see if this message is coming from the session that they just established with A. Okay, so it will check the session ID to see if the message is on the right lane. So now, this is to check session ID. And next is the presentation layer to check the format of the message. This is picture. This is a picture. You put it in that picture. Maybe it is JPEG picture. It is PNP. It is PNP format picture to check. Okay. Then finally, that message will arrive at the application layer. Okay. This message will arrive at the application layer. Okay, and they will see it as HTTP traffic. From there, you can receive the message. The server will receive the message, will interpret the message. It now depends on the request of system A at that moment. Okay, if the request of system A is to send me this picture or help me save this picture, it will do it. Okay, if system A is another system, maybe they are just exchanging picture. Maybe you are just exchanging a picture with your friend. Let's say this is you, and this is your friend. Let me use this. Let's say this is you. Let's say this is you, and this is your friend. And you just sent a picture, maybe through cable or through Bluetooth or whatever. This is the process that it will follow. So it is the application layer. It is at the application layer that you will finally receive the picture. Okay, maybe through your own Facebook as well, or download the picture to your system, see that it's a JPEG picture, and you'll be like, wow, this is a nice picture and all of that. Okay, so this communication that do take place between two systems is breakdown into layers. Okay, it's breakdown into layers, and these layers is what is called OSI layer model. OSI layer model.